Okay, so we're on example number 6, and we're to solve 2x equals, and I'll kind of write in yellow, 2x equals the square root of 28x minus 29, all subtracting 3. And if possible, we want to get the radical alone. I'm going to tell you that on the quiz that you're going to take, there will be a problem like this, and it will be a challenging problem, okay? So I try to always, every once in a while, I'll give you a little more challenging problem. So right away, you want to know that the quiz problem, like these solving radical equations, is going to be a challenging problem. In this one, we just added 3, so we got 2x plus 3 equal to that square root quantity. We squared both sides, and then once we squared both sides at this step, we have a radical, or excuse me, a quadratic equation, and so then our job was to find the roots or the zeros of that quadratic equation. We left off right here. Just a reminder, if this has a common factor, we can just divide that out. When we divide the left side by 4, we get x squared minus 4x minus 5. When we divide the right side by 4, we get 0 divided by 4, which is still 0. So then our next step is to factor this if we can. And by all means, if you want to use the quadratic formula, that will work as well. And so what multiplies to be x squared, x, and x? I need something that multiplies to be negative 5 and has a sum of negative 4. And what is that? Negative 5 and positive 1. And so then mathematically, I'm setting each of those factors equal to 0, because if two things multiply to be 0, and if either one of them is 0, then the product will be 0. So x equals negative 1, x minus 5 equals 0 here, so x equals positive 5. The little thing you have to be really aware of is to make sure that you check your answers back in the original. So we got x equals negative 1 and x equals 5. When we check that in the original, 2 times negative 1 is equal to the square root of 28 times negative 1 plus 29 minus 3. This is negative 2 over here. And what can happen is it can happen that when we get our x value and we put that in, we get square root of a negative, and so it's not a real number. In this case, that's negative 28 plus 29, so it's the square root of 1, and so it's 1 minus 3, and so that's negative 2. So this answer works. And then we'll just check 5 as well. 2 times 5, which is 10, square root of, 28 times 5 plus 29, minus 3. This is 10. I'm just going to guess that that is 13, and then when we subtract 3, we'll get 10. And you can check that on a calculator. I have it here, 140 plus 29 is 169, and so then that will be the square root of 169 is 13. So this one worked out, and both of those answers are solutions to this problem. So that's the basic process, and now we'll do one that doesn't have a square root. It has a cube root. Same thing. We have to cube both sides. A little trickier if that's a binomial on one side cubed, then you have to multiply it by itself and then take that answer times another one. In this case, it's all going to be numerical. So 12 equals the cube root of, in parentheses, x minus 2 squared plus 8. Our first job is to get one side of the equal sign with the radical alone, if we can do that. And so in this case, we'll subtract 8. And then in there, we get 4 equals the cube root of, parentheses, x minus 2, in parentheses squared. Now, for this one, our big thing is to just get rid of that radical. Since it's a cube root, we have to do what? We have to do what with it? Cube it, right? So we'll cube this side. we'll cube that side. This stuff that's inside just is going to stay the way it is. 4 to the third, 4 times 4 is 16, times 4 again, 64. So we get 64 equals the cube root, and cubed just gives us what's in under that radical, x minus 2 in parentheses squared. Now, it is still x minus 2 in parentheses squared, so we have to multiply that out. So 64 equals x squared. Please remember, I think it was the last test in, or last quiz in here, that some people were squaring something like that and getting x squared minus or plus 4. And don't forget that middle term. The middle term is negative 2 times x, which is negative 2x, double that, so minus 4x. The last term is plus 4. And then get one side equal to 0. It's probably easiest to get that side equal to 0. Oops, minus 4 minus 4x. And when I subtract 64, it'll be minus 64 and plus 4. Oops, minus 60 for that one, since I subtracted 64 from both sides. So once I have that, I can factor that again, and this one, what multiplies, to be 60 and subtracts to be 4? 10 and 6. So I can get x and x, 10 and 6 multiply, since I want it to be negative, a minus and a plus, x equals negative 6, x equals positive 10. There's my two answers. Again, I want to check them. And by the way, you always want to go to the very beginning and check again as we go through. So it's 12 equals the cube root of x minus 2 in parentheses squared plus 8. So really it's just putting in those numbers. The cube root of negative 6 minus 2 in parentheses squared plus 8, the cube root of negative 8 squared, oops, plus 8. Negative 8 squared is what? 64. Cube root of 64 is what? 4. 4 times 4 is 16 times 4. 4 plus 8 is 12. So that one checked out. So that answer is good. And then we'll check 10. The cube root of 10 minus 2, oops, in parentheses squared plus 8. Can I tell that that's going to work right away? Because it's the cube root of 8 squared plus 8. So from there, it'll be kind of the same. So that one worked also. So all of our answers so far have worked out. Of course, we should anticipate what's going to happen in the next problem. Something's not going to work, right? And so our next problem is our challenging problem. And this is the one where, I just tell you anytime you have a radical, check those solutions to make sure that there's not an extraneous root. An extraneous root means you did everything perfectly right, but when you put it back in the original, it doesn't work. So these are solutions, because it's a solution, that do not satisfy the original equation. So it is important to check for extraneous roots. So this is the challenging problem that you want to be able to do. The square root of x plus 1 equals 1 plus the square root of 2x minus 12. Okay, now up until this point, we've tried to get the radical alone on one side of the equation. Well, here's a radical alone on one side of the equation, but there's radicals on both sides, right? And so when that happens, actually, you would like one of them to be alone if you can get it to be. So we've got one of them alone, and you want the other one just on the other side. it does not, it's not to your advantage, as actually it just gets a little ickier if you put the radicals on the same side. So this is as good as we can get it before we square both sides. So now we're going to square both sides. The left side super easy, the right side not so much. And I'm actually going to, I think I'm going to just put a little workbox over here. And in this workbox, the left side, I am not worried at all about because I have the square root of x plus 1 squared. When we square root and square, they just get rid of each other. It'll be x plus 1. I'm already happy about that. It's this 1 plus the square root of 2x minus 12 in parentheses squared that I'm a little more concerned about. So that one, I might actually write it as 2 sets of parentheses and FOIL it out. So I'm actually just going to write it once here because we have people who are gone, just so that you can see it a little better. So I'm going to take 1 plus the square root of 2x minus 12 times 1 plus the square root of 2x minus 12. There's nothing here that you can't do. You all know how to do all of these steps, but the trickiness is just that there's a lot of steps to it. And so we're going to still have a radical when we do this. And so then when we put it back in over there, we're going to still have to get our radical alone, and we're going to have to square it a second time. So that's what makes this a little trickier. So I'm just going to FOIL this. First terms, 1 times 1 is 1. Outside terms is plus 1 of these square roots of plus square root of 2x minus 12. Inside is one of these again, plus square root of 2x minus 12. And last terms, when I multiply square root of 2x minus 12 times square root of 2x minus 12, I just get 2x minus 12. So I can just write plus 2x minus 12. So that's what happens there. Just like when I do those in my head, I'm going to have 2 of this middle term. So, and I can kind of combine some other things. So I'm actually going to write this one first. So I'm going to have 2 square roots of 2x minus 12. And then I'm going to have this plus 2x, because that's just right there. And then I have the positive 1 and the minus 12. That's going to be minus 11. Okay, so now we're going to take, and I'll write just with this yellow marker and then get rid of it. We're going to take that stuff, which is equal to this, and we're just going to put that in right there. And then on this side, we're going to square that. And so then I'll just get rid of all that yellow. And so then in this one, the square root of x plus 1 in parentheses squared is just x plus 1 equals, I did all that work. This is 2 square root of 2x minus 12. And then make sure that plus 2x is outside of there, and then minus 11. Now, in a way, it's just like the old problems that we did in the last 2 problems. Now I have an equation with a single radical in it. So my job is to get that radical alone, and then I'm going to square both sides again. So the first thing I'm going to do, and is it okay if I subtract 2x and add 11 at the same time, right? So we'll subtract 2x and add 11, minus 2x and add 11. And so then we get negative x plus 12. Oh, my x didn't turn out very well. Equals 2 the square root of 2x minus 12. Now, I did say get the radical alone, but I'm also going to be kind of an intelligent person, like we all are. And I'm going to say, okay, if I want to get that completely alone and divide by 2, I'll have the radical completely alone. But this is going to be a fraction then, right? And so, that's not that desirable. And it's okay since these are factors. When I square this, I'm not going to get that kind of mess that I got over there, right? Even with that 2 out there. So I can leave the 2 there if I want. If I divide both sides by 2, that's okay too. But if I leave it there, it just makes it easier for me in the moment, I guess is how I'll say that. Whoops. And so now that's alone enough. And now I'm going to square both sides. I might think of this um, and carefully kind of contemplate that, what that's going to be. And when I square negative x squared, and if you have to write it out and FOIL it out, that's fine. But negative x squared, do you agree, is x squared? Or negative x times negative x is x squared. This will be minus 12x, and then times 2 minus 24x. This will be 144 equals, then just be careful that this 2 becomes squared, so it's 4. But then the square root of all this stuff squared just becomes all that stuff. But then make sure you put it in parentheses so that you don't kind of lose it as you go. And now it's just back to what we've looked at before. And if I remember right, this is kind of an ugly problem, but that's okay. So x squared minus 24x plus 144 equals 8x minus, what's 4 times 12? 48. And then I'll subtract 8x, and I'll add 48. And so then over here I get x squared. What's minus 24 minus 8? Minus 32x. What's 144 plus 48? 192 equals 0. Now, granted, that's kind of ugly to factor. Do you agree? Could I use the quadratic formula if I wanted to? I can do whatever, whatever works the best for me. What do you want to do? Do you want to just figure it out, or? Okay, go ahead, figure it out. I need something that multiplies to be 192 and has a sum of negative 32. I want to know who has it first. Okay, we've got it. It's minus 24 and minus 8. And so, I knew that takes a little bit. On your quiz, I would try to make it so that the factoring of this isn't quite so intensive. So x equals 24, x equals 8 are the two answers that we get there. And then I do want to check, and we're already anticipating things might not work out. So I can't see the original problem, so I'm just going to write it here. It's the square root of x plus 1 equals 1 plus the square root of 2x minus 12. And so let's try 24. So 24 plus 1 is 25. Square root of 25 is 5. And over here, 1 plus the square root of 2 times 24 minus 12. What's 24 times 2? 48. 48 minus 12 is, so 1 plus the square root of 36. What's the square root of 36? 6 plus 1 plus 6, so that's 7. Does 24 work? And notice it didn't even give us something that is not a real number. It just doesn't work. But it has to do with, the fact that we have that radical. So then we'll check 8. And could it happen that neither of them work? It could. We have hopes for 8 still. Square root of 8 plus 1, square root of 9, 3. 1 plus square root of 2 times 8 minus 12. What's 2 times 8? Minus 12 is 4. 1 plus the square root of 4. Square root of 4 is 1 plus 2, 3. That one works, and we've got it. Okay? So there's nothing that you can't do in this problem, but it is a long problem. I grant you that. And I'm announcing today, and I know there are people who are not here, but I'll probably announce it again. On your next quiz, the problem like this problem is a challenging problem. And so it is one that will be a little bit challenging. Now, the only thing I really am going to have us do, since there's people gone, is just set up this next set of notes. And so this is polynomial equations. Can you graph and model real-world data with polynomial functions? So set this up and write your essential question that I'm asking that you write now. Can you graph and analyze power and radical functions? Oh, excuse me, can you graph, I'm sorry, can you graph and model real world data with polynomial functions? And then those of you who are here today can use the rest of your time. Homework 1 is due on Monday, and so you can use your time to work on that quietly.